So, as we start section 5.3 today, it starts off really just reviewing what we have covered. So, they've given us a right triangle here, and if this is the angle of interest, okay, and they have labeled this as side X, this is side Y, and this is our hypotenuse, which they're calling R. We have referenced it in terms of opposite, adjacent, and hypotenuse, but we'll go ahead and use the ratios they're giving us here, and then you're going to fill in whether it's an adjacent, an opposite, or hypotenuse, all right? So, would you say that length Y in this diagram, it would have what position in reference to angle A? Would it is the opposite side. So it is the opposite side to angle A, and X would be which side? The adjacent. The adjacent side to angle A. So let's go through and practice to be sure we've got these ratios down. Sine of angle A is the ratio Y over R, which we would typically say is what over what? Perfect. Opposite over hypotenuse. Tell me about cosine. What's that ratio? Good. It is the adjacent over the hypotenuse. Tangent? Opposite over adjacent. Excellent. All right. Why do you think cosecant is written across from sine? Because it's the reciprocal. And so when I flip it, instead of opposite over hypotenuse, it is? Excellent. Same thing is true about secant and cosine. They're reciprocals. So secant is? And the cotangent is adjacent over hypotenuse. Very good. Okay. So you want to make, adjacent over opposite. Thank you. Okay. So you want to make sure you know those. Look at this down here. We have all three side lengths shown in this right triangle. And so all we're asked to do is to provide the sine, the cosine, and the tangent for angle A and for angle B. So let's first look at angle A. And if I asked you what would be the ratio for sine of angle A, so I'm going to put one little mark here to remind us that this is the sine. Which side is opposite?
36.
Over, what's our hypotenuse?
85.
Does that make sense? Okay. And then we'll go ahead and get the cosine of that same angle. It would have to be what? 77 over 85. And that would mean our tangent for angle A is?
36 over 77.
Good. Opposite over adjacent is 36 over 77. Now, regardless of whether I'm looking at angle A or angle B, everybody is in agreement that 85 is the hypotenuse, right? So with the fact that this triangle's turned a little differently from how we're used to looking at it, if it helps to write hypotenuse next to that, just so you don't get mixed up and think it's an adjacent, then go ahead and write hypotenuse there. Now, I want you to notice something. Let's find the sine of angle B. So instead of looking at angle A, I'm going to put 2 marks here and tell me what would be the sine of angle B. Yeah, the opposite over the hypotenuse is 77 over 85. And the cosine of angle B is 36 over 85, and then tell me about the tangent of angle B. That's going to be, for angle B, that would end up being opposite over adjacent, which is 77 over 36. Now, tell me, do you notice any kind of interesting relationship? Do you see some of these ratios being repeated? So the sine of angle A actually is the same thing as what of angle B? The cosine of angle B. And the cosine of angle A matches the sine of angle B. That's because these are co-functions, all right? So when the co appears there, it's because they have a special relationship. If we're in a triangle, then the sine of one of the acute angles, we'll call it angle B, will always be the same value as the cosine of the other acute angle. I mean, doesn't that make sense that if I'm looking at one angle, the opposite side for that angle is going to end up being the adjacent side of the other angle? So that's why these are co-functions. They're going to give you the same ratio if you take the sine of one acute angle and compare it to the cosine of the other acute angle. Now, did you notice anything, or what do you think would be true about the tangent of angle A? So if I'm looking at angle A, that's an opposite over adjacent. That's going to be the same as what from angle B? The cotangent from angle B. You can see why we call these co-functions, okay? Cotangent is the co-function of tangent, because if I were to go to the other angle, then the relationship for the cotangent of that angle would match what the tangent was of the other one. All right, third one, secant. Notice these are the ones that are, they don't start with co, all right? And so the secant of angle A would have to be the same as what of angle B, because secant is what over what? Hypotenuse over, yeah, because the secant was the reciprocal of cosine. So it's hypotenuse over adjacent, which is C over B. If I'm looking at angle B, then this is what relationship? Hypotenuse over, instead of adjacent, it's opposite, and hypotenuse over opposite is cosecant. So that's why these are called co-functions. It would be the other angle in the triangle that would give me the same value as whatever the original of that function was. So the secant, its co-function is cosecant. Okay, tangent, cotangent, sine, cosine. So here's a way to kind of remember this. Your co-function identities. If I'm looking at angle A, the sine of angle A will always be equal to, now remember, we said it's the other acute angle. Since it's a right triangle, it means I've got a 90-degree angle in it. What would those other two angles have to add up to be? Because all the angles in a right triangle have to add up to be what? 180. All the angles in any triangle will add up to be 180. But since it's a right triangle, it means those two acute angles have to add up to be 90. So in order to figure out, if I didn't know what the angle measures were, I should know that if angle A is, say, 30 degrees, the sine of 30 degrees is going to be the same as the cosine of 90 minus 30, which is 60. So in other words, these two angle measures are going to add up to be 90. These are going to be complementary. The cosine of angle A would be equal to the sine of 90 minus A, and so forth. Okay? So co-function values of complementary angles are equal. So let's see if we can rewrite these in terms of the co-function. The sine of 9 degrees would be the same ratio as the cosine of what? 90 minus 9, which is 81 degrees. Very good. That's all I'm going to have to do is make sure that these two angles add up to be 90. And these will be equivalent. Bless you. Okay, cotangent is 76. What would be the co-function that's equivalent to that? Tangent of 14 degrees. Do y'all agree with that? Because these two added up would give me 90. And the cosecant of 45 is equivalent to the secant of 45 degrees. Very good. All right, so far this seems pretty easy, right? Then, let's look at this. We're going to find trig values for a 60-degree triangle. One of the things we will be looking at are some special right triangles. You guys remember doing anything with that in high school? So special right triangles will be 30, 60, 90 or 45, 45, 90. Okay, so let's talk about this one when we have a 60-degree angle in a triangle. And so here's what you want to keep in perspective. My longer side will always be across from the larger angle. Okay, now in a right triangle, does it make sense? That's why the hypotenuse is always going to be the longest side, because 90 degrees is going to be the largest angle inside that triangle. So there, my hypotenuse for sure is across from my 90-degree angle every time. Now, if I have two other angles, I got a 60-degree and a 30-degree in this triangle. Wouldn't it make sense that the longer side is going to be across from the 60-degree angle? The shortest side is going to be across from the 30. You want to keep that in mind, and there is a special ratio that exists for any 30, 60, 90, and it's this. Across from the 30-degree angle, you're going to have a side length of 1, okay? Across from the 60-degree angle, you get a square root of 3, and across from the 90-degree angle is 2. So it is a 1 square root of 3, 2 ratio. Now you got to make sure you understand which number is bigger, 2 or the square root of 3. I hope you know 2 is. Just to kind of show you, if I were to put square root of 3 in the calculator, that's only 1.73 something. All right, so don't get confused on that. 3 and square root of 3 are not the same number. That's why the hypotenuse is going to be 2. And then across from the 30-degree angle is a value of 1. And then we'll get that square root of 3 across from the 60. So let's see if we can figure out how to fill this in from looking at this particular triangle. So for the 60-degree angle, what would you tell me is the sine ratio? Exactly, square root of 3 over 2, because that is opposite over hypotenuse. Now, we're still looking at the 60-degree angle. What would be the cosine? 1 over 2. Tell me about tangent. Tangent is opposite over adjacent. So square root of 3 over 1 is just what? Square root of 3. It's okay if it cleans up and it's not a fraction anymore. We're going to simplify it. Now, my cotangent is
1 square root of 3 over 2.
Right. Remember, it's going to be the reciprocal of the tangent. So if I flip that, it's 1 over the square root of 3, and when I rationalize it, it turns into the square root of 3 over 3. Okay, y'all give me a signal. Do we have a thumbs up, thumbs down, or somewhere in the middle so far? Good? All right. Secant, that's got to be what? First of all, it's the reciprocal of cosine, so the secant is 2. And the cosecant would be,
2 square root of 3.
well, it'll be 2 over the square root of 3. So yes, when we rationalize, you get 2 square root of 3 over 3. All right, so we have filled out what all those trig ratios would be on a 60-degree angle. Now, let's talk about the 30-degree angle. This will also kind of reinforce the idea we talked about a minute ago with cofunctions, because if I'm looking at the 30-degree angle, the sine, tell me one more time, it's what ratio? Opposite over hypotenuse. If I go opposite over hypotenuse, I've got what? 1/2. But we just said a minute ago that the sine of a 30-degree angle would match what? The cosine of a 60-degree angle. So that relationship showing up here, you can either use the triangle or you can use the relationship. What would the cosine of 30 degrees be? Very good. Square root of 3 over 2. Cosine of 30 is adjacent over hypotenuse. Tell me about tangent. Tangent of 30. Good. It's opposite over adjacent. So 1 over the square root of 3 is square root of 3 over 3, which is going to be the same as the cotangent of 60. That'll match the tangent of 30. Now, the cotangent of 30 is what? Square root of 3, because it matches the tangent of 60. What would be the secant of 30 degrees? Secant is the reciprocal of, which one? Well, it's going to be the cofunction of the cosecant, right? And it's the reciprocal of the cosine. So yes, either way, you can get it or you can pull it out of the triangle. And we're going to get 2 over square root of 3, which is 2 square roots of 3 over 3. And that's going to mean that the cosecant of 30 is 2. Because 1 over 2 was the cosine of 60. Oh, I'm sorry. Didn't mean to look at that one. We wanted to look at the secant of 30, which is 2. And that's going to match the cosecant, or the secant of 60 was 2. That's going to match the cosecant of 30. Okay? So we just kind of covered 3 different ways you could think about how to find these. Bottom line, if you know your ratios and you draw your triangle, can you get all of them just by looking at the triangle? Now, the one that's not up here that I'm going to draw it in for you is the 45, 45, 90. So in this triangle, these have the same value. What does that tell you about these 2 legs? If these 2 angles are the same, then the legs are also the same. And so the ratio on a 45, 45, 90 is 1, 1, square root of 2. Does that make sense? Because if these legs are the same, the easiest number to use is 1. And if I plug into Pythagorean theorem, can you see why the hypotenuse has to be square root of 2? Absolutely. This ratio holds as well. That's all you're doing is using Pythagorean theorem to find these side lengths. Basically, if you go down to the smallest value that you could put on one of these side lengths. So when we get a side length of 1, then we're going to have these others that will be set into place. Can I multiply any of these by a certain, like can I multiply everything in this triangle by 3 and have 3, 3, 3 square root of 2? Absolutely. But it's always going to reduce down to be, this is the simplest form, the reduced form for all of these side lengths. Now, look at this guy. Your sine for 45 degrees is going to be what? Doesn't matter which one of these angles I'm looking at. Sine is? Yeah, because it's opposite over hypotenuse. And that gives me square root of 2 over 2. What would my cosine be? Same thing. My tangent, though, is kind of nice. It's what? 1. I get 1 over 1, which is 1. Same thing for the cotangent. Now, what would be my secant? My secant is hypotenuse over adjacent. So it's just going to be square root of 2, isn't it? Instead of 1 over square root of 2, it's going to be square root of 2 over 1. And same thing for the cosecant. All right, so those are going to be really important. You need to know these 2 triangles. I would encourage you, know how to sketch them out, label these sides, and then anytime you are asked to supply any trig ratio on a special right triangle, you'll know how to find it just from the triangle. I would draw that instead of filling out a table, personally. But we at least have covered where they came from. So let's talk a bit about reference angles. A reference angle for an angle theta, written theta prime, is the positive acute angle made by the terminal side of angle A and the x-axis. Okay? So we're going to make sure we find a reference angle always by using which axis? The x. Remember when I said make sure you drop your perpendicular to the x-axis? It's really important that that's the way you draw it, because this reference angle needs to be between that side, or the angle itself compared to the x-axis, okay? So let's see if we can figure out what the reference angle would be for these angles. And to a certain extent, this is kind of review. So we've got 294 degrees. First of all, tell me a little bit about what quadrant we're in. Which one?
Fourth.
Okay, fourth, because I know this is 90, this is 180, this is 270. So it's somewhere between 270 and 360. Okay, now that's where 294 degrees goes. But my reference angle, now here's why I'm saying be careful that you would always draw your perpendicular to the x-axis. I'll never go to the y. I'm always going to go either up or down to get to the x. So what would be the angle that's inside my triangle? It's this one, correct? And what would that reference angle be? Good, 360 minus 294, and that's going to be how many degrees? 66? Is that right? Okay, that's exactly how you would find it. So if I needed to come up with the sine of 294 degrees or the tangent of 294 degrees, I would need to be able to do this, figure out which quadrant I'm in, see what that triangle looks like, and then I've got to know what's this angle measure here. That's the one I'm using, okay? Now, what would you do with 883? Okay, first of all, this has definitely gone around more than one full rotation. So how many degrees is it in one full circle? 360. I know I can take away one 360. Do you think I could take away two? Because 360 times 2 is 720. So let's subtract out 720 from this guy, and let's see what we have. 3 minus 0 is 3. 8 minus 2 is 6. And 8 minus 7 is 1. So we should be looking for where a 163-degree angle would go. Which quadrant do you think that is? Looks like quadrant 2. So basically, here's 883 degrees. You go around one time, that's 360. Go around a second time, that's 720. And then I'm going to come over here, and 163 degrees is probably something like that. So this is a total of 883 degrees if I've used all the revolutions. But this means this is my terminal side. This is where I'm going to stop. So what would be my reference angle? If I drop that perpendicular to the x-axis, this is the angle that I'm looking for here. All right, and how would you find it? Very good. You got a couple of different ways you could do it. I would say, since I know from here to here is 163 degrees, if I had gone all the way to here, it would be 180. So if I did 180 minus 163, I'm going to get 17 degrees. So my reference angle is 17 degrees. All right, so far so good? All right, so no questions yet, correct? All righty, then let's look at this page. Now, if we're in first quadrant, we know there's no adjustment that has to be made. We're good. But if we're in the second quadrant, what did we just do to come up with this angle? Excellent. You would do 180 minus whatever that angle theta is that you had for here. Like in our case, the one we just looked at, it was 163 degrees. Quadrant 1, we know it's just whatever the angle is. There's no adjustment that needs to be made. Now, think about when you're in quadrant 3. If I go all the way to here, well, if I go 270 minus this, it would give me this angle. Is that the one I want? No, this one's going to be a little different. What do you think I would do? I could take, well, think about it like this. This is my whole angle theta. So it might be something like 200 or 210. How would I get just this part? Subtract 180. So instead of 180 minus the angle, you would do the angle minus 180. Okay? Because I've gone past 180, and then if I take 180 out, it'll give me this part right here. And then if I'm in the fourth quadrant, how would I come up with it? Let's say I'm at something like 330 degrees. How would I get this part? There you go. If I had gone all the way to here, it would be 360. So I need to do 360 minus whatever this is. 360 minus theta. Okay? Put my little degree signs on there. All right. So let's see if we could do this. Find the values of the 6 trig functions for 225 degrees. What's the first thing you need to figure out? Let's figure out which quadrant we're in. Where do you think 225 belongs? 1, 2, 3, or 4? I believe you are right. Somewhere in quadrant 3 should be 225 degrees. Now, my perpendicular goes which way? Always to which axis? The x. So that means I've got to go up to get here. And how am I going to figure out this angle measure? There you go. So if I do 225 minus 180, I've got 45, don't I? Oh, that's kind of nice because that's one of my special right triangles, isn't it? Yeah, I'm going to sketch out this 45, 45, 90 just to make sure we remember. What did we say the legs were? 45, 45, 90? 1, 1. Hypotenuse is square root of 2. So if this is a 45 degree angle here, now I'm in the third quadrant. So tell me about the SIGN of this side. Is it positive or negative? That's negative. So that's a -1. What about this one? Positive or negative? That's also negative. -1. Hypotenuse will always be a positive value. So you might want to go ahead and label it based on the quadrant you're in. And now let's see if we can come up with the sine of 225 degrees. It would be how much? Opposite over hypotenuse. So opposite over hypotenuse is -1 over square root of 2, which turns into negative square root of 2 over 2, right? Okay, you guys slow me down if we go too fast. Talk to me about the cosine of 225 degrees. Same thing, because it's going to be adjacent over hypotenuse, which will also be negative square root of 2 over 2. Now, what about the tangent of 225? It's going to end up being positive, isn't it? Because a -1 over a -1 just turns into +1. All right, we've got 3 of them. Let's get the reciprocal functions. The reciprocal of sine is cosecant. So let's talk about the cosecant of 225. It's going to be what? Instead of opposite over hypotenuse, it's hypotenuse over opposite, which means it is square root of 2 over -1, which just cleans up to be negative square root of 2, right? And that would mean that the secant is same thing. Now let's get the cotangent of 225. It's what? It's also 1, because if I flip that, it still ends up being -1 over -1, which simplifies to be +1. All right, we're whipping through these pages. That's good. So we went through and we looked at those quadrantal angles. I guess really the last 2 lessons. Let's see if you remember. We had something to help us remember sine and cosine. Quadrantal angles are those angles that are on an axis, right? 0, 90, 180, 270, 360. If I want to know what the sine value is, what did I tell you could remember to help? It's 5 letters. Ahala, yes, because it starts on the axis. The sine of 0 is 0. If I'm talking about the cosine, we said that was what? Hala. It starts high. So it starts at positive because all of the sine and cosine ratio values have to be between what numbers? Between a high of positive 1 and a low of negative 1. All right, so we're kind of reviewing a lot of different things here, okay? You'll never get undefined with sine or cosine. It's always going to be a ratio value between the negative 1 and the positive 1. Now, we're going to talk about when it's not a quadrantal angle. So it is something like, it could be a nice special right triangle, a 30-degree or 45 or a 60-degree angle, but it could also be a 54 or a 217-degree angle. So here's what you're going to need to make sure you do. First of all, if the angle is larger than 360, you guys knew to do this a minute ago, you better do what? Subtract out 360 as many times as you can so that you've got an angle that's between 0 and 360 that you're trying to work with. So like when we did 883 a minute ago, we knew we could take out 2 360s. We took out 720, all right? Find the reference angle that will be in the triangle after you've located that terminal side and you drop your perpendicular. We got to know what the reference angle is in the triangle. Then we're going to get the trig function values for the reference angle, and we got to pay close attention to signs because if we're not in the first quadrant, we got to know where things might be negative or positive. Now, we didn't do one of these, so tell me what's different when we talk about the sine of negative 150. I'm not moving counterclockwise, I'm moving clockwise. So that means this thing isn't going to end up where positive 150 would be. If I'm moving in a negative direction, which quadrant will I be in? I'm going to be in quadrant 3 because this would be negative 90. This would be negative 180. So I'm probably somewhere in there if this is a negative 150 degrees. Now, draw your perpendicular, and what do I need to find? What do we call this angle here? It's your reference angle. Good. So what's going to be the reference angle on this one? If I've gone 150 degrees this direction, then if I've gone all the way to here, it would be 180. What's missing? Yeah, this is a 30-degree angle. Now, the negative here just told me the direction I was moving, but I still know if I'm looking for the ratios, I don't have to put a negative 30 in here. I just need to know what's the angle inside the triangle. That's what it means when it's reference angle. So this gave me the direction to know where to put the terminal side. I just need to know the angle measure in here. Did they kind of give us a nice one? Because do we already know something about a 30, 60, 90 triangle? Let's see if you can tell me how to label these sides correctly. First of all, what's going to be the shortest side or the smallest side in a 30, 60, 90? And it's a length of 1, and you said it's opposite what? The 30-degree angle. So would y'all agree this is where the 1 goes? Now, if I'm in the third quadrant, is it positive or negative? That's a negative. Good. All right, that means this angle is 60. And how long would the hypotenuse be in a 30, 60, 90? Oh, be careful. It's the longest side, and that's 2. And that means that the side across from 60 is the square root of 3. Is it positive or negative? It's negative. That's on the negative end of the x-axis. That's how we would label that thing, right? Now, looking at my diagram, what would you tell me that the sine of negative 150 is? It's using this reference angle. Sine is what ratio? Opposite over hypotenuse. So that gives me negative 1 over 2. Make sense? Okay. Cotangent of 780. I want to give you the opportunity to try to do this one yourself. So I'm going to walk around and Okay, you guys were doing a good job with this one. So how many 360s could you take out of 780? So if you subtracted 720, you came up with cotangent of 60 degrees. Basically, we need to know where a 60-degree angle ends up. That's what quadrant. You guys did that really well. So we have a 60-degree angle inside quadrant 1, and that was one of our special right triangles. Now, talk to me about side lengths. What did you put across from 60? That has a length of square root of 3. That means this part would be the 30-degree angle, so what's the side length here? And then what's the hypotenuse? 2. And if I'm in the first quadrant, what are my SIGNs for each of these sides? All positive. So if they're all positive, all I have to do is look at this. Cotangent's what over what? Adjacent over opposite. So adjacent over opposite was 1 over square root of 3, which rationalizes to be square root of 3 over 3. All right, are we feeling, give me a thumbs up, thumbs down, or how are we doing? All right, good.
It's helping me to draw the triangle where I understand it.
Absolutely.
Instead of trying to like think of what the adjacent, just flipping it around where it's the same every time.
I agree. That's why on this one, I sketched it this way before I labeled over here. I think you've got an excellent point. A lot of times, if you'll go ahead and draw it as a first quadrant triangle and get those ratios on there, then it'll help you put it on if you happen not to be in the first quadrant, get your signs right. Good. All right, let's look at this one. What if we are looking for what value we could have for angle theta? Remember, that's going to be the angle that would, okay, hold on a second. Let me make sure I use the terminology they're using here. I believe they were putting the prime sign after it to indicate when it's a reference angle. So this is asking us to find what the actual angle measure degree, not the reference angle, but the angle values between 0 and 360 degrees. And that means there could be more than one of these angles that would have a sine ratio of negative square root of 3 over 2. All right, so do you understand what the question is asking for? It's basically saying, figure out how many quadrants between 0 and 360 degrees would give you a sine ratio that's negative with these values. Now, if you think for a second, how many quadrants would give negative sine values? Okay, if you were to sketch it out, remember, we think all students take calculus. So, and this is telling us where signs are positive. All signs are positive here. Sine and its reciprocal is positive here. That means sine is negative in quadrants 3 and 4. So far, is that making sense? All right. So what I need to figure out would be if I had an angle in quadrant 3 and I had an angle in quadrant 4. I'm just going to go ahead and sketch these in to see what the triangles would look like. And what I need to figure out is if the ratio is a negative square root of 3 over 2, and this is my angle I'm looking at, sine is what over what? Opposite over hypotenuse. It means this side would have to be the square root of 3. The hypotenuse is 2, and since it's negative, my hypotenuse is never negative. This is negative, right? So I'd have a negative square root of 3 over 2 here. I would also, for this 60-degree angle, have a negative square root of 3 over 2 here. And that looks like a special right triangle, doesn't it? Because what would this side length have to be? Yeah, it would, and then it's going to be a negative 1 here, it's going to be a positive 1 here. But what I'm interested in is what would be the degree measure to get to here, and what would be the degree measure to get all the way to here. Can we figure that out? All right, so tell me how you would do it. What's going to be for the one in quadrant 3, that's how many degrees? It's how far to get here? 180 plus how many more degrees?
30.
What angle was right here?
Let's do
That was a 60-degree angle, wasn't it? So that would be 180 plus 60, which is 240. Now, the one that's in quadrant 4, how do I figure this one out? If I'm going all the way to here, what's the easiest way to get that one? Remember, how do we find?
360 minus 60.
There you go. We have to go all the way to 360 and then subtract 60. So 360 minus 60 is 300 degrees. These are the two possible values between 0 and 360 degrees that would give us this sine ratio. All right, so we're putting lots of pieces together here. This is our last page of notes in this section, so you guys are doing well. If we're evaluating trig functions of angles that are given in degrees, and let's say it's not a special right triangle. So if I asked you to find the sine of 13 degrees, I have absolutely no way of doing that unless I have a scientific or a graphing calculator. Or if you're really old school, I'll let you know how old I am. Back when I was in high school, did you know these little basic, they didn't even exist yet, okay? We had tables in the back of our textbook that gave values for square roots, that gave values for trig ratios, and you had to look all those puppies up in a table. Plus, you had to know how, I mean, think about it. We had to use these relationships because it didn't list it for all 6 trig values. It would give you the sine, the cosine, the tangent, and if you needed a cosecant, you had to know how to be able to figure it out. Yeah, there was a lot that went into that. So, you know, praise the Lord, you guys have this thing because it is so nice. But here's the thing, if you're using a scientific calculator, we haven't yet talked about radians, but it is another way of measuring angles. So here's what you need to know. If it's this calculator, to check the way your calculator is set, you use this button right here that says mode. And if you look on the 3rd line, you've got the option between radians and degrees. So if we're working with degrees, you need to make sure that you turn it onto degrees here. If your calculator is a different type of calculator from this, I promise you, you still have that setting somewhere because it's going to let you use either degrees or radians. And so you need to make sure you're working in degrees if you're asked to evaluate degrees. This would also give you the ability to double check your answers on those special right triangles, but keep in mind, if the value, like on the one we just did, we had square root of 3 over 2 for our sine ratio in a 60-degree triangle. If I were to put in the sine of 60 degrees in here, it gives me a decimal approximation because the square root of 3 is an irrational number, right? So that's not going to give me an exact answer in the calculator. What I could do, though, is I could type in square root of 3 and then divide that by 2 and see if it looks like it's the same decimal number. And it is, okay? So you can kind of double check yourself, but the calculator itself will not give you those exact values when an irrational number is involved. So you need to make sure you realize that. And by the way, we will have some limitations on what you get to use calculator for on this first test. So you won't have it on everything. Part of the time you got to show me you know how to do it without the calculator. So we got to make sure that we are set in degree mode if our angles are given to us in degrees, and that's all we're going to work with right now. I have no idea why this little cent sign is here. It should be minutes. Okay, remember how we talked about you can divide degrees into smaller sections? So this is 68 degrees, 53 minutes. Now, we had a degree setting in the calculator. I didn't see anything that talked about minutes. So if I wanted to find the tangent of 68 degrees in 43 minutes, do you have any idea how I'm going to have to put that in? How many minutes are there in 1 degree? 60. Could I make a fraction out of it? That's what you're going to have to do. So you're going to type in tangent, and then when you put in your angle measure, in parentheses, you'd want to put 68 plus 43 divided by 60. Okay? So let's see what happens if we do that. Does that make sense? All right, and that has to be in a parentheses. So I'm going to find my tangent button. I'm going to type in 68 plus, and because I'm putting a fraction in, I want to go ahead and put that in another parentheses just to make sure we don't have any mistakes with order of operations. So the tangent of 68 degrees, 43 minutes is, and this says, let's approximate it. I'm going to ask you round 4 places to the right of the decimal. What would you put on your paper for this? 2.571. Excellent. 2.5671. So very quick reminder on rounding. If I'm going 4 places to the right of the decimal, it's the digit after that that tells me whether I need to round up or drop off. If I round up, it's because this digit has to be what? 5 or greater. As long as it's 5 or greater, I'll round up. If it is something that is less than 5, then I'll just drop off the extra digits. Okay, now this one's already in decimal form. You guys type that in, cosine of 193.622 degrees, and let's see if we can get that rounded to 4 decimal points. So before you tell me what you get, okay, tell me which quadrant I would be in if it's 193 degrees. And if it's in the 3rd quadrant, what SIGN should I get for the cosine? Did your calculator give you a negative value? What about the rest of you guys? If you typed in the cosine of 193.622, you got a negative value, right? And so rounded 4 places to the right of the decimal is what? Negative 0.9719. Okay, so it made sure that it gave us the right SIGN for the quadrant we were in. Now I could make the adjustment manually if I wanted to do so, but we checked and it gave us the right sign. Okay, this one is in which quadrant? Cosecant of 35.8471 degrees. That's a 1st quadrant. I know it should be positive. Have you typed that one in yet? So how do you type that one in? Do you have a button for cosecant? No, so we're going to have to figure out how we get that. So if I'm trying to find the cosecant of 35.8471, I'm going to have to use a relationship with either a sine, a cosine, or a tangent to figure this out. So what can I do? Because cosecant is the reciprocal of sine, couldn't I type in 1 divided by the sine of this angle? Does that make sense? Because a reciprocal means that you're going to take whatever this is and you flip it. So if you think of this as this over 1, when I flip it, it's going to be 1 over the sine of that. So let's try typing that in. Now if I do 1 divided by, I would go ahead and open up a parentheses just to make sure the calculator completely understands the entire denominator will be the sine of 35.8471. And I know it was in the 1st quadrant. I was expecting it to be positive, and it is. Rounded to 4 decimal places, we have what? 1 point? That's it. 1.7076. So we've gotten that, we've gotten that, we've gotten that. Now, I'm curious, is there any problem with tangent or cosecant being values that are not between -1 and +1? Remember? We said sine and cosine have to be between -1 and +1, right? Was there any restriction on these others? No, in fact, the cosecant and the secant can't be between -1 and +1, remember?
They have to be very.
Yeah, they can equal 1 or -1, but they can't be anything between those values. They're going to have to be something either greater than 1 or less than -1. All right, what would you do with the secant of -287? How do you think we get that one in the calculator? Okay, so my reciprocal would be the cosine. So you're telling me you would type in what? How do you take the reciprocal of this? 1 over the cosine of -287. Now, one thing we might want to think about, this is a negative reference angle. So if I were going a -287 degrees, what quadrant am I in?
First.
Well, there's -90, -180, -270. So yes, it is going to be in a first quadrant. It should be a positive value, right? All right, let's find out. So if you put in 1 divided by, and then we'll put in the cosine of -287. Oops, I think I put 1 too many in there. Is that what you get? And rounded to 4 places, I've got 3.42 for the last 2 digits. 03. All right, we still doing well? Okay. Now, there's one other thing we haven't done yet. What if you were told what, say, the cosine value is, the ratio value, and you were asked to find the angle? Could you do that? Yes, we are going to, it's called finding the inverse or the arc cosine or arctangent or arcsine. It simply means the angle whose cosine is this. So there is a way to do it. Right now we're only going to look at first quadrant angles, but let me show you on your calculator where these buttons are. You know where sine, cosine, and tangent are. When you see that little -1 above it, it is not raised to the -1 power. It means it is the angle whose sine, or the inverse sine, or the angle whose cosine. Wow, that's an interesting sound. Okay, so if I know the ratio, then what I'm going to put into the calculator will be this. And what it should give me back will be the angle measure that would make it true. So I am looking for what the measure of angle Q is. So if I hit secant and cosine, then I can type in the ratio value, 0.921185441. And when I hit enter, because I'm in degrees, this is giving me the degree approximation for the angle measure. Now remember, this probably was something that was irrational. So when I put in this many decimals, it's quite a few, but it's still rounded, okay? So we're going to round the angle measure, and let's round this one 2 places to the right of the decimal. So you would tell me angle Q is about how many degrees? 22.90 degrees. Now, is the 0 important there? It is if I tell you round 2 places to the right of the decimal, because even though 8999 rounds up to 0.90, if I don't put the 0 and I gave you the instruction to round 2 places to the right, it would make it appear that it rounded, it was exactly 22.9 degrees, and it's not. We rounded it to 22.90, so that's why that 0 is important. It indicates that it was rounded. What are we going to have to do on this one? On this one, we just hit the inverse cosine or the arc cosine button. Do you have an arc cotangent button? So I'm going to have to do both of them. I'm going to have to get the inverse and I'm going to have to use the arc tangent. Now let's kind of think our way through this. What do you think we're going to need to do first? Okay, so the cotangent ratio is this. Wouldn't that mean that the tangent ratio would have to be 1 over this? And if that's true, then I should be able to do the arc tangent of and then type it in this way. Does that make sense? So I used my reciprocal function first, and then I can take the arc tangent. So let's see what we get when we do that. If we do secant tangent, and we have 1 divided by, and then the denominator is 1.446647. That looks like this would be about 34.65 degrees for angle Q.